Hello guys, welcome on Tesla Adventures. In this video today we are going to discuss the bimetallic strip, and this bimetallic strip is very handful and very useful in fuses which are in our home to cut off the additional electricity which can cause damage to the electrical instruments at our home. So you can see that as name suggests, there are two metals which are combinedly joined together to form this bimetallic strip, and you can see that at room temperature this strip is straight, and at higher temperature, if we increase the temperature, this strip will take a curved form. It will bend towards the metal which has the lower expansion coefficient. Obviously you can see that if these two metals are rigidly joined together, and obviously we know that brass and steel are two different metals, so their expansion coefficients would be different, and the expansion coefficient of brass is greater than steel, so brass will expand more, but obviously they are rigidly connected to each other. Therefore brass will be on the concave side, in fact the convex side, and steel will be on the concave side of the strip, because concave side has a shorter length. So the expansion in the brass will be greater than the expansion in the steel, and therefore brass will be on the convex side. So now we see that how it is used in that fuses. So you can see that this is a fuse which is connected, and electricity supply is going on. Now if additional electricity is coming in the fuse, then obviously due to the heat loss, due to the current flowing in this strip and heat loss, this strip will expand more, and it is created in such a way such that this outer material has a more expansion coefficient. So if this outer material expands more and inner material expands less, then we can see that this switch will get open, and due to its opening the current will be cut off, and no additional current will flow from this bimetallic strip, and the electrical devices which are in our home would be safeguarded. Now let us discuss the calculations of bimetallic strip. Now this is a bimetallic strip, and there are two metals of coefficient of linear expansions alpha 1 and alpha 2. The length of this bimetallic strip is L0, and we have increased the temperature, and we are assuming that alpha 1 is greater than alpha 2. So if alpha 1 is greater than alpha 2, then this bimetallic strip, which is having a greater expansion coefficient, will be on the convex side, and this one would be on the concave side, like that. And you can see that we have assumed that the width of these two bimetallic strip is same, and we have also assumed that width will not change because width is quite small in comparison to the length. So we are assuming that width of these two bimetallic strip would remain the same. So you can see that what we have to do, we have to find out this radius. So you can see that each part, let us suppose that this edge of this strip and this edge of this strip. So if this strip would be in a circular arc form, then obviously the length of this edge would be less than the length of this edge. Okay, so we are taking the average length of these two, which is denoted by this length, which is this line which is going through center of mass. So we can say that the length of this line for the first strip is L1, and L1 would be equal to L0 into 1 plus alpha 1 delta t, and the length of this strip would be L2, and L2 will be equal to L0 1 plus alpha 2 delta t. Now we know that theta is equal to arc upon radius and arc is equal to theta into radius. So theta is this one and radius, now radius for this line will be the distance of this line from the center, and this distance is r plus d by 2. So this arc length L1 will be equal to theta into radius is r plus d by 2, and therefore we can substitute the value of L1, which is L0 1 plus alpha 1 delta t is equal to theta into r plus d by 2. And then in the similar way we can write down that L2 is equal to this theta into this length. So this length will be equal to r, radius, this is radius, minus d by 2. So this would be radius minus d by 2 into theta. So this L2 will be L0 1 plus alpha 2 delta t. Now let us divide these two equations. So r plus d by 2 upon r minus d by 2 will be equal to 1 plus alpha 1 delta t upon 1 plus alpha 2 delta t. Now from this equation we can find out the value of r. Okay, and if r is given and d is given, then we can find out alpha 1 if alpha 2 is given and alpha 2 if alpha 1 is given. Okay, so we can find out the either thing from this equation, and this is the bimetallic strip. Thank you.